Welcome to Algorithm video series. Today in this tutorial, we'll solve first occurrence, last occurrence and count of occurrence problem. First, let's solve first occurrence problem. Here is the problem statement. Here, input of our program is a sorted list of numbers with duplicate elements and a target element, and output is index of the first occurrence of that given target element. For example, here we can see a sorted list of numbers with duplicate elements, right? Here target is 30 and index of first occurrence of 30 is 2 here. That's why output is 2. First occurrence in a list of numbers means the position or index where a particular number appears for the very first time in the list. For example, in this list, if I want to find the first occurrence of 10, then that is at index 0. It appears only once. So here first occurrence and last occurrence is same, that is at index 0. But if I take element as 40, 40 appears at index 3 and 4, right? So if we talk about first occurrence of 40 in this list, that is at index 3. Here last index of 40 is at index 4. First occurrence is the index or position where a particular number appears for the very first time in the list of numbers. To find the index of first occurrence of the given target element, we can use linear search algorithm. As we know, in linear search, we'll search in sequential order, right? That's why in linear search, we'll get the index of the first occurrence of the target element easily. For example, here we can see that. But here in the problem statement, it is mentioned that the input is sorted list of numbers with duplicate elements, right? So when we are using sorted list, it is better to use binary search algorithm to find the target element and also to find the first occurrence of the target element. But here we can't use normal binary search algorithm because in normal binary search, as soon as we find the target, we'll return the index, right? But here the element may appear multiple times because duplicate elements are allowed here. And we want to find the first position. So we need to modify binary search algorithm. So what we need to do is, first we need to find the middle element, then compare the middle element with the target element. If it is equal, then don't return the index like we do in the normal binary search. Here we need to store that index in case it turns out to be first occurrence of that target element. And we need to continue search in the left side to see if there is earlier one. If find another target on left, update the result. If not, mid remains the result. When middle element is our target element, what we need to do is first we need to store that index because it can be the first occurrence of that target element. Next, we need to continue search in the left side to see if there is earlier one. If we find another target in the left side, then we need to update the result, that is index. If not, mid remains our result. And next, if mid element is not equal to target element, then we need to check whether target is greater than middle element. If it is true, then we need to search in the right side. Otherwise, we need to search in the left side, like normal binary search. What is the difference between normal binary search and modified binary search? Here you can see, when middle element becomes equal to target element, in the normal binary search, we'll return its index and we are done. But in the modified binary search, we are searching for the first occurrence of the target element. When the middle element equals to the target, there are two possibilities. First one is, it is the first occurrence of the target element in the list. And the second possibility is, it is not the first occurrence of the target element in the list. That means, the same number appears earlier. So we have to look to the left because here input is a sorted list with duplicate elements. That's why in the modified binary search algorithm, when target becomes equal to middle element, we'll store the index first and next we'll continue search in the left side. Here duplicate elements are allowed. Finding target once doesn't mean it is the first time it appears. So that's why store the index of the middle element and keep searching in the left half to see the same value appears earlier. Next, let's take an example. Alright, here we have list of numbers, sorted list of numbers, and these are all the index. Okay, first step is we need to find the middle element. Here low plus high truncated division 2. So we'll get middle as 3, right? So this is our middle element. Then compare the middle element with the target. So let's take target as 30. So middle element is equal to target. Here it is true. In this condition 30 is equal to 30. So target is found. Now what we need to do? We need to store the index of this middle element because it can be the first occurrence of our target element. So let's take a variable and we'll store its index. Next we need to continue search in the left side. So here to search in the left side I need to take high equal to mid minus 1. So this is our search area now. Again find the middle element. 0 plus 2 truncated division 2. So middle is 1. So this is our middle. Compare middle with the target element, that is 20 is equal to 30. Here it is false, right? Then compare whether the target element is greater than the middle element. Here yes, 20 is less than 30. So 30 is greater than 20. So what we need to do? We need to search in the right side of the middle element. So now low becomes mid plus 1. We'll do the same thing with the normal binary search, right? Now this is our low. Next again find the middle element. Now this is our search area. So again find the middle element. 2 plus 2 truncated division 2. So we'll get 2 as the middle element. So this will become our middle element. Then compare the middle element with the target element. Here 30 is equal to 30. True. So when it is true, that means we found another target element. So what we need to do is we need to update this variable now. We need to store this index. Here index is 2. So answer is 2. This variable will store the index of the first occurrence of the target element. So now update this. So here answer is 2. Next, what we need to do? We need to search in the left side. So I'll take high equal to mid minus 1. Here when high equal to mid minus 1, high becomes 1. Here low is greater than high. So now we need to stop the binary search. Here this variable holds the result, that is the index of first occurrence of the target element. Okay, let's take another example. First step, find the middle element. 7 truncated division 2, so we'll get 3, that is the middle element. Then compare middle with the target element. Let's take target as 22. Compare the middle element with target. Here it is true. So what we need to do? We need to store this index and we need to search in the left side. We need to check whether 22 is already present in the left side or not. So here to search in the left side, I need to take high equal to mid minus 1. Again find the middle element. Low plus high truncated division 2. So we'll get middle as 1. So this is our middle element. Compare middle element with the target element. 11 equal to 22. No, it is not. 11 is actually less than 22. So we need to search in the right side of the middle element. So low becomes this, mid plus 1. Now again we need to find the middle element. So here 2 plus 2 truncated division 2. So we'll get this as the middle element. Compare this middle element with the target element. 22 is equal to 22. True. It is true. So now we found another target element. So we need to update this index. We need to store this index now. Here again we need to check in the left side. High becomes mid minus 1. But here low is greater than high. So we need to stop the binary search. So answer is 2. Let's take another example. Here this is a list of numbers. Target is 111 and initially low is this, high is this. We need to find the middle element. So low plus high truncated division 2. So we'll get 3. So this is our middle element. Then compare the middle element with the target element. Here it is not equal and target is less than middle element. So when target is less than middle element, we need to search in the left area, right? So high becomes mid minus 1. Now high is mid minus 1. Here we need to repeat the same thing. We need to find the middle element. 0 plus 2 truncated division 2. We'll get this as our middle element. Compare the middle element with the target element. Here target is 111 and middle element is 111. It is equal. So we found our target. Now what we need to do is we need to first save that index because it can be our possible answer. Then we need to search in the left side. So to search in the left side, I'll take high as mid minus 1. So now high will point to this. Okay. Now we need to find the middle element. Low plus high truncated division 2. So we'll get this as middle element. Compare the middle element with the target element. Here 111 is equal to 111. So here we found another target element and we need to store this index now because this is the first occurrence of 111 now. So save that index. Next, we need to search in the left area. To search in the left side, I'll take high as mid minus 1. Now high point to minus 1. Now here you can see low becomes greater than high. So we need to stop binary search now. The first occurrence of target element, that is 111, is 0th index. Let's take another example. Here target is 444. So first find the middle element. So this is the middle element. Compare the middle element with the target. 222 is equal to 444. No, it is not. And here target is greater than the middle element. We need to search in the right side. So low becomes mid plus 1. This is our search area. Now find the middle element here in this search area. 4 plus 7, that is 11. 11 truncated division 2. So we'll get 5. This is middle element. Compare the element with the target element. Yes, it is true. Middle element is 444 and target element is also 444. So it is equal. So we need to store that index here. It can be the first occurrence of our target element. So store that index and search in the left side. Right? So here high becomes mid minus 1. So now high will point to this. Now this is our search area. Find the middle element. So we'll get this as mid. Compare middle element with the target element now. Here middle element is not equal to target element. So what we need to do? When it is not equal, then compare whether middle element is less than target element. Yes, middle element is less than target element. We need to search in the right side. So low becomes mid plus 1. But here we can see low is greater than high now. So in binary search, when low becomes greater than high, we need to stop. So here we need to stop and here our output is 5. That is the first occurrence of the target element, that is 444. Okay. So let's write the program. As I said, we can use linear search algorithm to find the first occurrence of the target element. No need to do any changes to linear search algorithm. Just use linear search algorithm. How many elements? Let's take 5. And here because problem statement says that it is a sorted list of numbers with duplicate elements, I'll enter elements like this. Then I'll enter target element as 30. Then we'll get index 2. Because linear search algorithms search in the sequential order, we'll get the first occurrence easily. So no need to modify the linear search algorithm. So next, let's talk about binary search algorithm. This is the normal binary search algorithm. When target becomes equal to middle element, we'll return its index. So let's save this and execute this and we'll see whether it works for the sorted list with the duplicate elements to find the first occurrence of the target element. So let's enter 5. Alright. So now I'll enter 20 as my target element. So we'll get index as 2. But actually we need output as 1 because the first occurrence of 20 is at index 1. That's why I said normal binary search doesn't work here. Because when target is found, it will return its index. But here we need to search for the first occurrence of the target element, right? So here we need to modify this binary search algorithm. We need to change this part. When target is equal to the middle element, what we need to do is we need to store that index first. For that, let's take a variable. Initially, I'll take its value as -1. And here, when target is equal to middle element, then store that index. Then continue search in the left side. For that, I'll take high equal to mid -1. Right? Next here, we need to return answer here. Here, this algorithm returns the index of first occurrence of the target element if target is present in the given list of numbers. If target is not present, then we'll return -1. So that's why initially I'll take answer equal to -1. If target is present here, then it will return the index of first occurrence of that element. Otherwise, it will return -1. Okay, now we are done. Let's save this and execute this. Let's enter 6. I'll enter 40. 40 is found at index 3. That is the first occurrence. Alright, so this is how we can find the first occurrence of the target element in the given sorted list of numbers with duplicate values. Okay, so this is about first occurrence problem. Next, let's talk about last occurrence problem. Here is the problem statement. So input of our program is a sorted list with duplicate elements and a target element. Output is last occurrence of the target element. For an example, here we have a sorted list. Our target is 30. Then our output is index 3, last occurrence of 30. Here 0, 1, 2, 3. In this list, this is the last occurrence of 30. Its index is 3, so output is 3. If an element appears multiple times in a sorted list, the last occurrence is the rightmost position of that element, and the first occurrence is the leftmost position of that element. And if an element appears only once in the sorted list, then that is the first and last occurrence of that element. Here in this example, if I take target as 30, then last occurrence of 30 is index 4. The first occurrence is index 2. If I take target as 20, it appears only once. So this is the first occurrence, and also this is the last occurrence of this element. Okay, so now how to find the last occurrence of the given target element in the sorted list containing duplicate elements. For this, I'll use binary search algorithm. But normal binary search algorithm doesn't work here, because in the normal binary search algorithm, we'll search for the target. Once it is found, we'll return its index and the message target is found. But here we want last occurrence of the target. Target can appear multiple times, and we want the last occurrence of the target. For an example, here if I take target as 30 and if I apply normal binary search algorithm to find the last occurrence. So in the binary search algorithm, I'll take this as low, this as high. This is our search area now. So we'll find the middle element first. So we'll get 3 as our middle element. Then we'll compare the target element with the middle element. Here 30 is equal to 30. I'll take target also 30. Here middle element is equal to target element. So what our binary search algorithm will do? It will return its index, right? What is its index? 3. So it will return answer as 3. But actually here last occurrence of 30 is at index 4. So we can't use normal binary search to find the last occurrence of the given target element. So what to do? We need to modify our binary search algorithm. First, we need to find the middle element like we do in the normal binary search algorithm. Then we'll compare the middle element with the target element. Next, if middle element is equal to target element, in the normal binary search algorithm, we'll return the index. But here, in the modified version, what we need to do is, when middle element is equal to target element, we need to first store that index, because it can be our possible answer. It can be the last occurrence of that target element. Okay, so first we need to store that index. Next, we need to continue search in the right side to see if element appears again. Because here we want last occurrence, we need to search in the right side of the middle element. If we find another target on the right side, then we need to update our result, that is the index. Initially, we'll store the index of the middle element. If we find another target, then we need to update that. If not, if we didn't find target element on the right side, then that means middle element is the last occurrence of the target element. So we'll return that index. So mid remains our result. Then here, if middle element is not equal to target element, then what? If middle element is less than the target element, then we'll search in the right side, like we do in the normal binary search. If it is false, then we'll search in the left side, like we do in the normal binary search. Here we need to modify this scenario. When middle element is equal to target element, then we need to store that index and we need to continue search in the right side of the middle element. So here we can see the difference between normal binary search and modified binary search. If you want to find the first occurrence of the target element, then we need to store the index of the middle element and we need to search in the left side. Here we want to find the last occurrence of the target element. So when target element is equal to middle element, we need to store that index and we need to continue search in the right side of the middle element. That is the difference between the first occurrence and last occurrence. Next, let's take few examples. Let's take target as 30. We want to find the last occurrence. So let's find the middle element. Low plus high truncated division 2. So we'll get index as 3. This is our middle element. Then compare 30 with target 30. It is true. Target is equal to middle element now. Now what we need to do? To find the last occurrence, first I need to store the index of the middle element. Because target is equal to middle element, I need to store the index. And now search in the right side of the middle element. For that, I'll take low equal to mid plus 1. So now this is our search area, right? Find the middle element now. So 4 plus 6 truncated division 2. So we'll get 5. And this is our middle element. Compare middle element with the target. 40 is equal to 30. No, it is not. Actually, middle element is greater than target element. So we need to search in the left side, right? High becomes mid minus 1 now. So high will point to here. Then we'll find the middle. So we'll get this as middle. Compare the middle element with the target element. It is equal. When target is equal to middle element, what we need to do? We need to store that index in this variable, right? So here now, answer is 4. Update this variable. Now, we need to search in the right side. When target is equal to middle element, we need to store that index. We need to search in the right side. To search in the right side, we need to take low equal to mid plus 1. So now, low becomes this one. But here you can see low is greater than high now, right? When low is greater than high, we need to stop binary search. So stop the search. And this variable will hold answer now, that is index 4. This is the last occurrence of our target element, that is 30. Let's take another example. Let's take target as 444. First find the middle element. 0 plus 7 truncated division 2. So we'll get 3. So this is our middle element. Compare the middle element with the target element. Middle element is not equal to target element. Then check whether target is greater than middle element. Yes, here target is greater than middle element. So when target is greater than middle element, this is a search area now. So again find the middle element. 4 plus 7, 11. 11 truncated division 2, 5. So we'll get this as our middle element. Compare the middle element with the target element. Yes, here target is equal to middle element. So store that index and search in the right side of the middle element. So low becomes mid plus 1. Now this is our search area. Again find the middle element. Low plus high truncated division 2. 6 plus 7, 13 truncated division 2. So we'll get 6. This is our middle element. Compare the middle element with the target element. Yes, it is true. So store its index and search in the right side. So here low becomes mid plus 1. So now this is our low and high. Find middle element and compare middle element with the target element. It is true. Then what we need to do? We need to update answer now. Answer is 7. Then we need to search in the right side of the middle element. So low becomes mid plus 1. Low is actually 8 now. Now low is greater than high. So we need to stop binary search. So this is our answer. That is 7. The last occurrence of 444 is at index 7. Let's take 111. Compare the middle element with the target element. Target is less than middle element. So search in the left side. High becomes mid minus 1. Now find the middle element again. Compare the middle element with the target. It is true. So store its index. Then search in the right side of the middle element. So here low becomes mid plus 1. So here now this is a search area. Find the middle element. Low plus high truncated division 2. So we'll get this as middle element. Compare the middle element with the target element. It is equal. So we need to store its index. So 2. And we need to search in the right side. So now to search in the right side, low becomes mid plus 1. Now low becomes 3. But here low is greater than high now. So we need to stop the search. Answer is 2. Next, let's write the program. Here we have a normal binary search algorithm. So let's modify this binary search algorithm to find the last occurrence of the target element. So for that, we need to modify this section. When middle element becomes target element, we need to store that index. For that, let's take a variable. Initially, we'll take its value as -1. Then here, instead of returning value, answer equal to mid, we'll store that index and we need to search in the right side of the middle element. To search in the right side, we need to take low equal to mid plus 1. And here, we need to return answer. If target is found, then this function will return the last occurrence of the target element. If target is not found, then it will return -1. That's why initially I took answer as -1. If target element is not found, then it will return -1. So no need to change anything else. Let's save this and execute this. Number of elements in the list, let's take 6. Enter the numbers in the ascending order, a sorted list. Let's enter target as last occurrences index 2. Last index is 4. Okay, so this is how we can find the last occurrence of the target element in the sorted list containing duplicate elements using binary search algorithm. Okay, so this is about last occurrence problem. Next, using first occurrence and last occurrence, we can calculate count of occurrence, that is how many times target appears in the given list of numbers. So next, let's talk about count of occurrence problem. Here is the problem statement. Given a sorted list containing duplicate elements and a target value, return the number of times the target appears in the list. Our input is a sorted list containing duplicate elements and a target value. Output is number of times the target appears in the list. For an example, here we have a sorted list with elements 10, 20, 30, 30, 30 and 30. Now our target is 30. Then we'll get output as 4. 30 appears 4 times in this list. 1, 2, 3, 4. Then if I take target as 10, output is 1. It appears only once. That's why output is 1. And we can solve this problem using different techniques. Here we'll talk about linear search method and binary search method. In linear search algorithm, we'll search for the target element in sequential order, right? Initially, we'll compare the target element with the first element of the list. Here, if I compare 10 with 30, 10 is equal to 30. No. Then we'll compare the next value with the target element. Here, 20 is equal to 30. No. Then let's compare next element of the list with the target element. 30 is equal to 30. True. So what I'll do is I'll take a variable, for example count, and I'll take count as 1 now. Because here target is found, I'll take count as 1. In the normal linear search, once the target is found, we'll return its index and we'll stop. But here we want to find how many times the target appears in the given list. So what I'll do is I'll continue searching and I'll go to the next element. Here next element is 30 and I'll compare that with the target element. Yes, it is true. So I'll take count as 2 now. Count of 30 is 2 now. Again, go to the next element. Here 30 is equal to 30. True. Count is 3. Again, go to the next element. 30 is equal to 30. Yes. Count is 4. Next, we don't have any other elements to check. List ends here. So count is 4 now. Our target value, that is 30, appears 4 times in our given list. Let's take our target as 10. Then compare the target element with the first element of the list, that is 10. 10 is equal to 10. True. This condition becomes true. So I'll take count as 1. Then go to the next element. Here 10 is equal to 20. Target is 10 and element is 20. No. Next, go to next element. 10 is equal to 30. No. 10 is equal to 30. No. Next, 10 is equal to 30. No. Again, 10 is equal to 30. No. So we don't have any other elements to check here. List ends here. So count is 1. 10 appears only once in the given list. We can modify linear search algorithm like this to calculate how many times target appears in the given list. But as we know, it is better to use binary search when we are dealing with the large data sets. And also here, as mentioned in the problem statement, list is a sorted list. So let's see how to solve this problem using binary search algorithm. Okay, in binary search what we can do is, first we can find the first occurrence of that target element using binary search. Then find the last occurrence of that target element using binary search. Then you can find the count using this formula, last index minus first index plus 1. Okay, let me explain this with an example. First what we need to do is, we need to find the first occurrence of the target element. So for example 10 here. So 10 is occurred at 0th index. Then you need to find the last occurrence. Here last occurrence is also at 0th index. Because 10 appears only once, this is the first and last occurrence of 10 in this list, right? So first index is also 0, last index is also 0. Then how to calculate count? Here last index minus first index plus 1. Why plus 1? That is because index starts from 0, right? Here we need count. That's why we need to add plus 1 here. So 0 minus 0 plus 1. So we'll get count as 1. True, right? Here 10 appears only once. So count is 1. Next, let's take another example. Okay, let's take target as 30. First calculate the first occurrence of 30. Here in this list, first occurrence of 30 is at index 2. Then the last index. Find the last occurrence of 30. Last occurrence is at 5th index. First occurrence is at index 2. Last occurrence is at index 5. Now here let's calculate this. 5 minus 2 plus 1. 5 minus 2 is 3. 3 plus 1 is 4. So total count is 4. 1, 2, 3, 4. So using binary search what we need to do is, first we need to calculate the first occurrence of the target element in the given list. We need to find the index. Then we need to find the index of the last occurrence of the target element in the given list. Then using this formula, that is last index minus first index plus 1, we can find the count. And how to find the first occurrence and last occurrence of the target element using binary search algorithm, we already discussed about this in the previous tutorial. So I'll give you the link of that in the description box. Alright, next let's write the program. Okay, here linear search. Let's modify this linear search algorithm first. Here in this linear search function, initially I'll take a variable count. Count is equal to 0. Let's go through the elements of the list one by one using for loop. Then compare the element of the list with the target element. Then here we don't want to return its index when target is found. We don't want to return its index. Instead of that, I'll take count is equal to count plus 1. I'll increment count and go to the next element. After searching entire list, then here we need to return count. Okay, so this linear search algorithm will find how many times target element appears in the list. Then here input is same, a list. Here we need a sorted list, remember that. Then a target element. Then here we'll call the linear search function. Here result is count, right? So if result is 0, then that means the target element is not present in the given list. So we can print that message. If it is not 0, then we can print here. Okay. Let's save this and execute this now. Let's take 5 elements. Let's enter the elements in the ascending order. Let's take 30. It appears 3 times. Let's enter 50. 50 appears 1 times. 5 is not found in this list. Okay, so this is how we can modify linear search algorithm to find how many times a target element appears in the given list. Next, let's talk about binary search algorithm. So in the binary search algorithm, what we need to do is first we need to find the first occurrence of the target element. Then we need to find the last occurrence of the target element in the given list. Then we need to use the count formula to find the count, right? So here, initially, let's change this function name. We'll use binary search, but modified binary search. Here I'll just change the name to first occurrence. Alright. Then here what we need to do, to find the first occurrence when target element is equal to middle element, we need to store that result. Let's take a variable answer equal to -1 initially. Then store the index and search in the left side. To search in the left side, I equal to mid -1. Here you need to return answer, right? Next here we need to find the last occurrence. So I'll copy this and let's define the function for last occurrence like this. Here let's change the function name to last occurrence. Here in the last occurrence, when target element is equal to middle element, we need to store the index and we need to search in the right side. So low equal to mid +1. Done. Okay, so this is first occurrence. Here last occurrence. Done. Next here for first index, call first occurrence. For the last index, last occurrence. Done, right? Call both these functions. We'll get first index and last index. Done. Next here, I'll check first index is not -1. So when we find first occurrence and last occurrence, if the function first occurrence return -1, that means target is not found, right? That's why I'll use this condition. You can use last index is not equal to -1 also, because if target is not present in the given list, we'll get -1 as the value for first index and last index. Both this function will return -1, right? Here I'll take first index is not equal to -1. Then how many times? That is, let's calculate that. Count is equal to last index minus first index plus 1. This is the formula. Then here you can print count times. Okay, done. Let's save this and execute this. Let's enter 6 elements. Enter the numbers in the ascending order. Okay. Let's enter 20. 20 appears 4 times. Correct. 5. Let's enter not found scenario. 6 is not found. 10 appears 1 times. Okay, so this is how you can use binary search algorithm to find how many times the target element appears in the given list. Okay, so this is about first occurrence, last occurrence and count of occurrence problem. That's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I'll meet you in next class. Till then, take care.